Let's learn in this video about GitHub Advanced Security and how it can add security to our DevOps pipelines in GitHub to implement proper DevSecOps. Despite the increasing developer awareness, security threats continue to rise. We can view in this graph the rising number of threats in the last years. In the software development lifecycle, we have multiple stages like development, build, test, QA, production, and we might discover issues and threats during those different stages. The cost of remediation will be much more higher once we reach or once we are near the production stage. So we have better to discover those issues earlier during the software development lifecycle, preferably during the development of the application, so that we keep the cost very low. So that for that reason, organizations want to shift security left. We want to focus more on the left here on the development lifecycle. For that shift left approach, we have here GitHub Advanced Security that will help us to shift left. So we would have multiple tools available for us like the dependency graph, advisory database, security alerts, dependency review, secret scanning, code scanning, branch protection, commit signing, and security overview. Today, we'll focus more on the code scanning section. Code scanning, that's a tool for finding vulnerabilities before they are merged into the code base with automated CodeQL scans. It integrates actually the results directly into the developer workflow and into our DevOps pipelines. We can also run custom queries and the community-powered GitHub query set. It's extensible. It will support not only CodeQL, which is developed by GitHub, but it will also support multiple other SAST tools developed by non-GitHub. So let's see here how CodeQL works. So we start first with the code base, where we go to build that code base, compile it, and then we go to extract the code into data, save it into a database. It's multiple tables. And then we use that database to extract some information using a querying language that is CodeQL. So we'll be using CodeQL QL compiler, and then you'll be using QL evaluator under the scenes. And at the end, we'll have our query results, which are the issues and the threats discovered within our application. Let's see how that works in the real life. So from within the GitHub portal, from here when I want to add a new workflow, I will have the security section here, and I will see multiple scanning tools available. One of them is CodeQL, but you can also see some other known tools like SonarQube, SonarCloud, Sneak, Fortify, and many more. Those are tools within the SAST category, which is the Static Application Security Testing. And CodeQL itself is an open source engine, that's open source project available on GitHub itself. When I choose that security pipeline using CodeQL, it will give me a pipeline that looks like this. It's a very simple pipeline that contains a job, call it analyze, that will go to run some steps developed specifically for CodeQL, which will go to check out the source code, initialize CodeQL, and then build the source code using CodeQL itself, and then performing CodeQL analysis, where here it will go to perform all that analysis and give us the results inside GitHub itself. Let's see how that pipeline will run inside GitHub. So here I will see the different checks and analysis done here for C# and done for JavaScript, for example. After that, we can go to one of the tasks within that pipeline, and if that is the perform CodeQL analysis, we can view here the results. So here discovered actually 227 results for the compilation message, and successfully extracted files are 670, and it created a database with 41,000 lines of C# code. Now to go to view the results, we can go to the code scanning section within the security section in GitHub, where here we can view the 25 security issues or threats or issues that were discovered by CodeQL, and we can go to select or click any one of these issues, and we'll get more details about that issue, like I have here with this controller. So it will discover the issue, it will explain to me why that is an issue, why that is not a good practice, and then it will give me the best practice or the recommendation or the mitigation to this issue. So here it will give me more documentation about how I can fix that issue. Let's see next a real demo on how this works. Let's learn in this video demonstration how to add security to our DevOps pipelines in GitHub using GitHub Advanced Security with CodeQL. So from here, I have an example of the findings that were found with CodeQL, and in this demo, I want to show you how I went into these results. So first of all, I'll start with the sample application that I have here, which is a sample.NET application where I have some models, controllers, and some C# code. So I want to go to scan this application. So to do that, I'll go to Actions and I'll go to create a new workflow and I'll implement CodeQL within that workflow. So I'll go to say here I want a new workflow. And then I scroll back to the security section where I find the workflows for security. And I'll find here, if I go to click view all, I will see multiple SAST tools that will allow me to scan my application source code and implement proper DevSecOps pipelines right here. So we have multiple options available right here. One of them is Sneak, and we can view also Sonar 45. And for my demo today, I'll continue with CodeQL, which is developed by GitHub itself. It's an integrated feature within GitHub Advanced Security. So I'll click to it, and this will go to provision a sample pipeline. So I can go to change this pipeline, but for the sake of this demo, I'll just keep it simple like this. This pipeline mainly will go to run each time I have a new commit or a new pull request, or based on a schedule on a cron. It will have one single job that is analyzed. So it will go to run on a machine that is specified here, Ubuntu latest, and it will require some permissions like writing into the security events so that I can find the findings within the security section. And because my code might contain multiple programming languages, like here in my case it's C# and JavaScript for the language, I create a matrix for that, and that will allow CodeQL to run each time for a specific programming language. Then on the steps, I'll start first by checking out the source code, and then I'll go to initialize CodeQL. So for that, I'm using this task here, github/CodeQL action/init. I'll run it for the specified language. So first run will run for C# and then it will go to run for JavaScript. Then I'll add another task here, two other tasks actually, auto build coming from the github/CodeQL action that will go to try to build the existing application. So if it's a C# application, it will go to compile it to generate the DLL files. I can do this either using this task that will make it a little bit easier for me, or I can use a custom task to do that. So I can use the .NET build, for example, or the .NET CLI tool in order to compile my .NET application. If I have Java application, maybe I'll be using Maven in order to do that. Then next, the last task here is the main task that will go to perform the CodeQL analysis. This one will go to use CodeQL action/analyze with version 2, and it will go to take the language and perform the analysis based on that, and then it will go to upload the findings within GitHub portal. Let's now go to try to run this CodeQL YAML pipeline. So I'll go to commit the changes. But by the way, I have already done that before this demo. So I have that CodeQL here. It's saved and it was triggered. For that now, if I go to the actions section from here, I will see that I would have two tasks or two jobs for that pipeline. One that will go to analyze the C# code and another one that will go to analyze the JavaScript code. Let's select the C# one, for example. If I go to click on auto build or actually perform CodeQL analysis, from here I will see the findings. So here I discovered actually 14 results and 3 results for the compilation messages. Inside the pipeline itself, I will not see the results actually, because here I see a step that is called uploading results. It will upload those results into the GitHub portal. So for that, if I switch here to security, I see here the number 3. Actually, that's because here in code scanning, within the vulnerability alerts, I see 3 alerts. Those 3 alerts are the one created by CodeQL. I can go to check those alerts. If I click here, then I will see a description for that alert. And if I click on show more here, I will view some recommendations and some examples on how to fix this issue. So the code I used in this demonstration is actually very light. So I have used another application that is the eShop on containers, which, by the way, you can find it into this GitHub repository. It's a very complete, let's say, a little bit of a complete application that contains multiple backends, and it's a microservice application. So it have lots of code source based on C#, TypeScript, and JavaScript. So I'll just fork this application by clicking on fork it right here, and then I have went into the actions from that repository and created a new action that uses CodeQL as I have done with the previous application. And then I can see the results here. So if I check perform CodeQL analysis from here, yes, because it's a very large application, I will see multiple results available. Like here I see 41,000 results available. So now next, if I go to security, I will see some of these results available within the code scanning. So if I check here, I will see those findings filtered by the severity. So those are the high one, the medium, and the low risk results. Let's click on the first one, for example. So here it's telling me user-controlled bypass of sensitive method. It tells me where that issue was discovered, in which method, which class, C# class. And then if here I go to show more, then again it will show me the recommendation and how I can go to fix this issue. Great. So when we went to the security section here in the vulnerability alerts, we have discovered today CodeQL with code scanning, but we still have 2 other tools that we can use. And I will try to cover these tools in the next videos, which are using Dependabot to detect dependencies for our application, and another tool that is secret scanning that will try to detect any secrets saved as plain text within my application.